All right, so this third chapter is all about transformations. So you guys have probably seen this stuff before, but I want to go over some definitions here. So the first one is rigid motions. Okay, so to define rigid motions, they are a class of transformation that preserves length and angle measure. Okay, so what we're talking about here is we are talking about our like rigid motions that we're going to use in this chapter are reflections, all right, which is this first section that we're going to go over. Translations and rotations. Okay, so those are our three types of rigid motions that we're going to talk about. So a reflection is like when you flip the object. Translation, you slide it. Rotation, you turn it. um, So those are our rigid motions. Now, rigid motion, you could also see it as isometry. So if you see the word isometry, it's the same thing as a rigid motion. Okay, isometry, rigid motion, same thing. Um, so moving on, just to give you guys some like examples of it. If you look over here underneath the one, there says, is each transformation a rigid motion, and then explain why or why not. So if we're looking at this, like if you look at the first one, A, okay, the figures look like they're the same. So, and the important part about this that I wanted to talk about is that we have this pre-image and image. Okay, so the pre-image and the image. The pre-image is the original object. The image is the object after it's been transformed in some way. Okay, after it's been rotated, reflected, or translated. So in that first one, the figure that's in black is the pre-image. That's the original object. And I think about this like if you take a picture, you have an image. So let's say you're looking at like a mountain. Okay, take a picture of the mountain, you have an image of the mountain. That's not the original figure. That's just an image of it. All right. So that mountain that you're looking at, when you're looking at it, that's the pre-image is what I think of. So pre-image is the original, image is after the transformation. So if you look at both of these, all right, we just got to see, do the figures look the same? In the first one they do, it looks like this is just going to be a rotation. All right. In the second, you can see the second one got big. So that's not a rigid motion because even though they look like the same figure, you can definitely tell that these sides are going to be longer in the image than the pre-image. Okay, so that is a rigid motion or an isometry. Next, guys, give me 1 second here. All right, so this first section, like I said, is all about reflections. So a reflection is just flipping something. So we have this, we have P there. P is at 4, 6. Okay, P is at 4, 6. And if we reflect this over the Y axis, okay, there's a couple ways to do this. So P is at 4, 6. You could count and go, all right, how far away is P from the Y axis? Okay, we count over, it's 4. Okay, we're going to count 4 units this way, find the coordinate. Okay. Now we also have a rule when we're reflecting over the y-axis, okay? So if we are reflecting over the y-axis, this is our rule. And if you look at the coordinates, it shouldn't be too difficult to figure out. So we're going to start off with the coordinates x comma y, okay? So any coordinate this is going to work for. And all we're going to do, and if you look here, we have to start out with 4, 6, okay? And then reflect it over here, and that x coordinate becomes negative. So I'm going to put a negative in front of the x, all right, and the y coordinate stays the same, okay? Now, if you look, like if we started out with negative 4, 6, okay, then we do negative 4, all right? If we do a negative times a negative, that would give us a positive. So that's how we kind of reflect it back, okay? So if we have 2 negatives, it's going to make a positive. So next is if we reflect over the x-axis, okay? So this time we're changing it up a little bit. We're going to reflect over the x-axis, which is right here. All right, there's our x-axis. And so if you look at this, we are starting off with 4, 6 again. And then we reflect it. We can do the same exact thing that we did before. We could count and go down and see that, hey, we're 6 units away. So we're going to do another 6 units. All right, count another 6 units past the x-axis. And if you look at the coordinates for this, again, we're starting off with 4, 6, and we end up with 4, -6, okay? So our rule for the x-axis, okay, our x-axis rule is this. And make sure you have these rules written down, all right, as you're watching this video. Please write these down. So the x-axis rules, if we start off with any coordinate x comma y, all right, what happens is this time the y coordinate is negative, okay? Or it would change back to positive. So basically, anytime we put that negative symbol in front of the x or the y, all it means is that we're changing the sign, okay? So 2 different ways to reflect the object. You can just count, okay? You can just count towards the line of reflection, all right? Or you could switch using our rules if we're reflecting over the x or y axis, okay, guys? And again, make sure you have these rules written down. So the next thing is reflecting across the line y equals x, okay? So if we reflect across the line y equals x, this is what we're going to do, okay? So we're starting out with this triangle here, and we have the coordinates of the pre-image of x, y, and z, okay? X, y, and z. And I will say this, just another like notation thing, how we write things is if you look down here, we have this x prime, y prime, and z prime. So that's how we read it, is x prime, okay? And all it is just an x with an apostrophe. And what it means is basically that that figure has undergone some type of transformation, and we're relating it back to the pre-image. It's not a different figure, but it's undergone some transformation, so it's in a new location or place or something like that, okay? So that's why we use that to kind of keep them together, but at the same time notice that they are 2 different figures. So for this one, if you look, we start out with these coordinates here for x, y, and z, okay? And we're reflecting over that line y equals x, which is just a diagonal line with the slope of 1. So you go up 1, over 1, up 1, over 1, all the way up there. So for this, if you notice, we have the coordinates here because it's kind of hard to count sideways. We're counting across boxes. And for z, it worked out, but it's not always going to work out real nice for us, okay? So for this, I would definitely use the rule when we're reflecting over the line y equals x, okay? And if you look at the coordinates, we're starting out with x at 5, -2, and then x prime, and I have this one done for you, is at -2, -5. So hopefully from that, we can kind of understand what's going on. Hopefully you're getting an image in your head. If you look at z, z is at 1, -1, 1. Z prime is at 1, -1. So hopefully at this point, you're like, oh, I'm getting it. So our rule when we're reflecting over the line y equals x, and this would be something to write down. We're starting off with the coordinate x comma y, okay? And after it undergoes the transformation, all we're going to do is we're just going to switch the coordinates and make it y comma x, okay? So that's all we did. So x was at -5, -2. So all we did to get x prime is we switched those coordinates, okay? And put the x coordinate into the y spot, put the y coordinate into the x spot. That's it. All right, so now the other type of reflection you might see is reflecting across the line y equals at -x. So this is just a diagonal line with a negative slope. So that's where, same thing, we're going in the negative direction. So it's going down 1 over 1, down 1 over 1, okay? Now, when we're doing this, and if you look, we have the coordinates u is at 3, -4. So 3, -4, and then we're going to look, again, because it's diagonal, it's kind of hard to count sideways, especially t. It's like 1, 1.5. It's kind of weird to count that way. So for this, u is at 3, -4. And then if we notice u prime is at 4, -3. Okay, 4, -3. So hopefully you're kind of formulating like what's different about this. And I think S is going to be the one that's easiest to see. So S is at -1, -6. S prime is at 6, 1. 6, 1. So this is what's going on here. Okay, this is what's going on here. So our rule for this one is we are going to flip the coordinates just like we did before. So we're going to start out with x comma y, and we're going to flip the coordinates and do y comma x. But this time we're also going to change their sign. So you started out with 3, -4, okay? And all we did to undergo the transformation is we put that x coordinate in the y spot, change the sign. We put the y coordinate in the x spot and change the sign. Okay, so that's what we're doing there. Same thing with S and S prime. S started out with -1, -6. All right, so put that x coordinate in the y spot, make it positive. Put the y coordinate in the x spot, again, change the sign. Now, if you look up above, so make sure you have this rule written down. But if you look up, we can kind of see that the 0, all right, that's the only time it gets kind of funky. 0, you just leave 0. Okay, so you're still going to flip it, but at the same time, you do not change the sign for that. Okay, so 0 is neither positive or negative. So, but that's it, guys, for reflection. So make sure if you have any questions, shoot me an email or ask a question during class. But good luck and have a good rest of your day.